Hi guys, welcome to the tutorial chapter 9. Today you have alternating current. This is the last tutorial video in physics 2. Okay, before I proceed with the solution, before I show you the answer, okay, I hope you already try the tutorial question. Okay, and you have your answer, your tutorial question in front of you, so it can help you to answer your problem, your question, and complete your answer for this tutorial chapter 9, alternating current. Okay, let's discuss. Okay, question 1, question 2. Okay, for question 1, you want to calculate one complete cycle of this power. You are given the value of the frequency 400 Hertz. Okay. Formula, I think you are very familiar with this. Formula T equal to 1 over F. Okay. Question 2, you are given the alternating current equation as a function of the time I equal to 5 sine 200 pi t. Okay, so you need to compare with general equation of the alternating current as a function of the time. Remember, formula equation I equal to I naught sine omega t. So you need to find the value of your peak current, the omega value, okay, from your equation. Okay, let's do the frequency of the alternating current. How to calculate the frequency? Omega equal to pi f. You need to apply this formula. I think also you are very familiar with this equation, this formula. Okay, omega, you have 200 pi. Substitute the value into your equation, the formula, and then you can solve for the frequency. Peak voltage, okay, V naught. VRMS equal to V naught divide by square root 2. You have your VRMS from your equation here, 330 volt. Okay, and then you can solve for the V naught peak voltage, the maximum value of your voltage. Next, IRMS. Okay, formula IRMS equal to I naught divided by square root 2. I naught from your equation here, which is equal to 5 ampere, substitute into your equation in here and solve for the IRMS. Next, peak power formula P naught, okay, equal to the I naught V naught. Okay, value for I naught, V naught, you can get from your previous answer. Okay, next, average power formula. Remember, to calculate the power average is equal to IRMS, VRMS. Okay, the IRMS, VRMS also from your answer, or VRMS you can get from your equation, from your question 330 volt. Okay, and then F, sketch a graph of current against time. Okay, let's read the graph here. The important is you need to label the maximum value of your current, refer to your equation formula for your alternating current as a function of the time. Okay, maximum is equal to 5. Okay, so you have a maximum, minimum, maximum positive, minimum is negative. Okay, and then label the time here, one complete cycle, which is equal to the period 0.01. Okay, second period you have 0.02. You can use the formula T equal to 1 over F. Okay, to calculate the one complete cycle or the period value. Okay, is it okay? Next, question 3, question 4, question 3, you are given the graph. Okay, so you need to find the value from your graph. Okay, you have a maximum of your current 3 ampere. You have your one complete cycle of the period is 4 millisecond. Careful with the unit. Okay, you have a time in the unit millisecond. Okay, so frequency from the period, from the one complete cycle, which is equal to 4 millisecond. Okay, T equal to 1 over F. Then you can calculate the frequency. Express second question expression to a right expression to represent the AC current. So you have your sine graph. Okay. Alternating current has a function of the time. So I equal to 3 sine omega t. So omega, how to calculate the omega? Is equal to pi f is equal to 500 pi. Substitute into your equation, then you got the expression. Okay, the equation of your alternating current has a function of the time. Okay, here. Next, what is the current when t is equal to 5.6 milliseconds? So you need to substitute the value of your time. Okay, 5.6 millisecond, convert into the second, 5.6 times 10 power negative 3. Okay, substitute into your equation of your alternating current as a function of the time and solve for the current. Okay. It's similar like question 4. Okay, 4C here, you want to calculate the voltage. You are given the equation or the formula. Okay, the alternating voltage has a function of the time. V equal to 12 sine 180t. Okay, you have V if you want to compare with the general equation formula for the alternating voltage as a function of the time. Okay, you have V equal to V naught sine omega t. Okay, so you can get the peak value here 12 equal to 12 volt. Okay, frequency omega from the omega value 180. Okay, is equal to 2 pi f. So for the frequency, and last C for C voltage. So for the V, substitute the T value 0.005 second into your equation. Okay, and then solve for the voltage here. Okay, remember, choose radian mode when using the calculator. The omega, okay, you have a term of the omega angular frequency unit is radian per second. So you need in the radian, okay. So you need to choose your mode calculator, okay, to the radian. If not, your final answer will be wrong. Okay, is it okay? Let's go to the next question. Question 8, question 9. Okay, question A, you have you are given the 10 volt, the AC supply you have 50, the frequency of your AC supply you have 50 hertz. Okay, and then from the value, okay, you need to calculate, okay, the value of your V naught because you want to sketch the graph, okay, voltage with the time, okay. The 10 volt, okay, is equal to the VRMS here. So substitute the 10 volt here for the VRMS and then solve for the peak voltage. Okay, you got 14.14, okay. And label on your graph, sine graph for your voltage, okay. And then don't forget to label the one complete cycle here. Okay, how to calculate one complete cycle again, okay. T equal to 1 over F. F, you have 50 hertz, okay. So label, okay. Is it okay for the graph? Okay, number 9 also, number 9 you have a graph, you are given the graph, you need to calculate, okay, the period, the angular frequency, the peak value and peak to peak value of the alternating current. I think you don't have a problem to calculate the period and then the angular frequency omega, okay, omega is equal to 2 pi f. Okay, and then peak value, the maximum value of your current, refer to your graph, you have a 3 ampere here. How about peak to peak? So peak to peak, you can refer to the arrow here, is refer to the length, maximum to the minimum. So total is equal to 3 plus 3 is equal to 6 ampere. Okay, careful here with the unit is millisecond. Okay, convert to unit SI for the time second. Okay, next question, question 5, question 6, question 7, question 10. Okay, you need to apply again the formula IRMS and the VRMS. Okay, VRMS, IRMS. Okay, remember in the current alternating voltage, you have a term for your IRMS and the VRMS. Okay, you don't have a term of the VRMS, IRMS in the direct current. And also you don't have a term of the maximum value of your voltage, the maximum value of your current in the direct current. But IRMS is not the same with the peak current, maximum value of your current. Okay, VRMS is not the same with the maximum value of your voltage. Okay, but here, okay, let's do question 7. Okay, question 7, you are given the value of your voltage 120 volt and the current value which is 10 ampere. Okay, the value of your voltage here is equal to the value of your VRMS, and the value of your current here is equal to the IRMS. Okay, so if you want to calculate the peak power here, by using the formula P naught equal to I naught V naught, you need to calculate the value of your I naught first. Okay, so refer back to this formula. Okay, you can calculate the I naught. Okay, and then you can calculate also the V naught because you are given the VRMS here and current here IRMS. Okay, is it okay for you? Okay, next question. Okay, next question, question 11, question 12, question 13. I divide into two subtopic. Okay, question 11, the problem, the question which is under the pure resistance in the AC circuit. Question 12, question 13, under the part pure capacitor in the AC circuit. Okay, question 11, okay, you are given the equation. Alternating current has a function of the time I equal to 3 sine 100 pi t. Okay, how to calculate IRMS? Okay, again, you need to apply this formula IRMS equal to I naught divided by square root 2 I naught from your equation which is equal to the 3 ampere. Okay, next, to calculate the VRMS, you need to apply Ohm's law equation formula. Okay, VRMS equal to the IRMS R, or if you have the peak also, you can apply this formula. Okay, so by using this formula, solve for the VRMS. Okay, question 12, question 13, you have your pure capacity in the AC circuit. Okay, remember you have your formula for the reactant of the capacitor or the capacitive reactance symbol by the XC here. Okay, it's referred to the resistance. Okay, in your AC circuit. Okay, formula equal to 1 over 2 pi Fc. Okay, that's the question 12 here. You are given the capacitance of a capacitor 100 microfarad. Okay, it's connected to 6 volt. 6 volt is referred to the VRMS. Okay, and then you have a frequency of your AC supply which is 50 Hertz. Okay, calculate the reactance of the capacitor, which is you need to calculate the XC. Formula 1 over 2 pi Fc, unit is ohm. Okay, because you want to calculate the resistance. But now your resistance is reactance of the capacitor because you have your capacitor in your circuit, in AC circuit. Okay, current flowing through the capacitor. Okay, you want to calculate the IRMS. Okay, you have a current. Okay, throw in your circuit means it's referred to the IRMS. Okay, after you got the value for your XC, okay, you have a value for your VRMS, which is 6 volt. Okay, so IRMS 6 divided by the XC value. Okay, is it okay? Question 13 is similar like question 12. Okay, you are given the value of the capacitance here. Okay, and then you have a VRMS 240 volt. Okay, frequency 50 hertz. How to calculate the capacitive reactance, the resistance, okay, in your circuit due to the capacitor. XC formula, okay, is equal to 1 over 2 pi FC. Please remember the formula for the XC, okay, capacitive reactance, okay. Next, the peak current, okay, I naught, okay. You have your value of your capacity reactance. You have a value for your V RMS. Okay, so you can apply, okay, this formula. Got the value to get the value of your IRMS first. After that, remember formula IRMS equal to the I naught divided by the square root 2. Okay, so you can get the value of your peak current, the maximum of your current from that equation. Okay, this equation. Okay, is it okay? So you need to know how to differentiate between the pure resistor and the pure capacitor. You have a different formula for each different question, different problem. Okay, please remember the question or the formula, the equation and the formula. Next question, which is under the RC in series circuit, question 14, question 15 here. Okay, you have your AC circuit. Okay, example here. Okay, refer to this figure. You have your AC source. Okay, connect with the resistor and capacitor in series. Okay, so you need to consider both the resistance value of your resistor and the capacitance value of a capacitor in your calculation, especially if you want to calculate the total of your impedance, the total of your resistance. Okay, so let's do question 14 here. 14, you have your AC source of 10 volt. Okay, 10 volt is equal to VRMS. Okay, and then you have a frequency 50 hertz. Okay, and then capacitance of the capacitor value 2 microfarad convert to farad, the unit SI for the capacitance. Okay, and then the resistance of a resistor 1 kilo ohm also convert to ohm. Okay, to unit SI for your resistance. Okay, current question, current flow in your circuit. Second, you need to calculate the voltage across the capacitor VC. Phase angle, the phi value between the applied EMF and the current. Okay. And then you have your average power displayed in your resistor, power average across the resistor. Okay, let's do the solution here. The solution A, you want to calculate the value of your current. Okay, if you refer to your question, you want to calculate the IRMS. Okay, the IRMS is equal to the value of your current flowing the circuit. Okay, must be the same. You have only one value of your current, IRMS, flowing in your circuit. Okay, before you calculate your current, the concept is similar how to calculate the current in the direct current. You need to calculate the total of your resistance first and then apply the Ohm's law. Okay, so here you have a term of your total of your resistance is impedance. The total of your resistance is equal to the Z, the impedance. So impedance formula, you need to consider the resistance value and the XC, the capacitive reactant XC. Okay, but before that, the formula to calculate the IRMS, okay, you have a formula for the impedance is equal to VRMS divided by IRMS. Okay, calculate the impedance. How to calculate your impedance? Apply this formula, square root R square plus XC square. Calculate the XC here by using the formula 1 over 2 pi FC. Okay, you got 1591.55 ohm. Remember, the unit for the capacitive reactant in unit is ohm. Okay, and then substitute into your formula of your impedance here, and then solve for the Z. You got 1879.14 ohm. Okay, and then substitute into your formula here to calculate the IRMS. Solve it and you got 5.32 times 10 power negative 3 ampere. Okay, of your IRMS. Is it okay? So you have a current, okay, in the circuit is equal to IRMS is equal to 5.32 times 10 power negative 3 ampere. Means you have a current across the resistor and across the capacitor is the same. Okay, so if you go to question next, let's go to question B. You want to calculate the voltage across the capacitor. Okay, remember the formula here. If you want to calculate the voltage across the resistor, okay, is equal to IR. If you want to calculate the voltage across the capacitor, formula is equal to IXC. Okay, so here you want to calculate the VC, formula IXC. You already calculate the value of your XC here. Okay, and then substitute into your formula here, time with the current across the capacitor. Okay, is the same with the IRMS. Okay, so you got the value of your voltage across the capacitor 8.5. Okay, the value here is depend on your value here, yeah. Okay, so you can get plus minus. Okay, next question C, you want to calculate the feed angle. Okay, you can refer to your question, angle. Okay, you have a formula XC over R. Okay, angle is the same. Okay, your question. So you got 10 tan phi, tan phi. So solve for the phi here. You got 58 degree. Okay. Next, the P average formula, the power, average power across the resistor. You must have a term of your R here. You need to consider in your calculation. Okay, you have a value of your current, which is IRMS. IRMS square times with the R, so you got the answer 0.0281. Okay, understand or not? The working, how to solve, which is related, the question, the problem, which is under the RC circuit. Remember, you need to consider both the resistance, okay, of your resistor and the resistance, what we call capacitive reactant AC in your capacitor. Okay, so formula you have Z equal to the square root R square plus XC square. And then by using the formula here to calculate the IRMS or the current in your circuit. Okay, let's do the question 15 here. Okay. Okay. Solution for number 15. I got the solution for number 15. Okay. You can refer to your question. Okay, you got given the information of the peak voltage. Okay, you have a term of V naught in your circuit, which is 18 volt. Okay, the frequency on your AC source you have 25 hertz. Okay, and then the capacitance value 200 times 10 power negative 6 farad. The value of your resistance of a resistor is 40 ohm. Okay, first, okay, you want to calculate the impedance, the total of your resistance in your circuit. So you need to consider the resistance and the capacitive reactance XC. Okay, so solve by using this formula Z equal to the square root R, the square root R square plus XC square. Calculate for the XC, you got 31.83 ohm. Okay, here the value of your XC formula. This is your formula. Don't forget the formula to calculate the XC. Okay, then the final answer here for the Z 51.12 ohm. Okay, second question, you want to calculate the IRMS, which is equal to the I flow in the circuit. The value must be the same. Okay, IRMS with the I flow in your circuit, and then also the value of your current across the resistor must be the same with the current IRMS across the capacitor. You have only one value of your current across your circuit. Okay, so here again you have a formula to calculate the V. Okay, the impedance equal to VRMS divided by IRMS, and solve for the IRMS here 0. You got the final answer 0.25 ampere. Okay, VRMS divided by the IRMS. Okay, how to calculate the VRMS here? You are given the value of your V naught here. Okay, so refer here formula. Okay, VRMS equal to V naught divided by square root 2. So first here to calculate the VRMS 12.73 volt, then substitute into your formula here. Okay, then you got answer for the IRMS 0.25 ampere. Third question, you want to calculate the VRMS across the capacitor. Okay, so how to calculate the voltage, the VRMS across the capacitor? You need to consider capacitive reactance XC in your calculation. Okay, formula VC equal to IXC, I is equal to the IRMS. IRMS value 0.25 times with 31.83. Okay, and then you got the final answer for your voltage or the VRMS across the capacitor. Okay, understand or not? For these two questions, the two problems which is under the RC circuit. Okay, you have your capacitor, you have resistance in your circuit, then you need to consider in your calculation the value of your resistance and the capacitive reactance. Okay, next. Next, you have a part of the transformer. Okay. I think this part is not difficult. Okay. Remember, you have a formula for the transformer, the relationship between the, you have a term of the secondary coil, primary coil, number of turn in the secondary, number of turn in the primary, the end term, okay? And then is equal to Vs divided by Vp, the voltage in the secondary, divided by the voltage in the primary coil, and then also is equal to the current in the primary coil and the current divided by current in the secondary coil. Okay, you need to apply this formula to solve your question, to solve your problem. Okay, you have a question, number 16, number 17, 18, 19, and the last question 20, okay, which is under the transformer. Okay, so numbers, let's look number 16, 17 here. You are given the ratio. So ratio, what the meaning of the ratio here? Is equal to 8. So means NS over NP. Okay, so equal to the 8. Then solve for the secondary voltage. Okay, by applying this formula. Okay, question 17 also you have a term of the ratio, term ratio. So again, ratio NS over NP is equal to 0.1. Okay, so now here they want you to calculate the voltage in the primary. Okay, all. So again, you need to apply this formula. Okay, it goes in with the question 18. You need to apply the formula of your transformer. Okay, question 19 also. Okay. Question 20. Let's look the answer, the solution for question 20. Now you are given the equation of your alternating voltage as a function of the time V equal to 340 sine 100 pi t. Compare with your general equation of the alternating voltage as a function of the time V equal to V naught sine omega t. So you need to find the value. Okay, you can get the value info from your equation here. Okay, to solve your question, to solve your answer, to solve your problem. Okay, if you refer to your question, 600 turn on each primary coil. Okay, you have n number 1800 turn in the secondary coil. Okay, here you have an equation of your alternating voltage across the primary coil. Okay, and then you are given the resistance of a resistor 10 kilo ohm is connected to the secondary coil. Okay, calculate for the transformer V voltage RMS input the voltage here. Okay, the voltage V RMS output. Okay, peak value for the peak output in the voltage. Okay, mean output power. Okay, let's suit the answer. Again, you need to apply the formula of the transformer. Okay, so question 20, NP 60 turn, and as you have 1800 turn. Okay, formula here. So from the formula here, the V naught, okay, which is equal to 340 volt. Okay, you have across the primary coil question 1 VRMS for the input here. Okay, so formula you need to apply VRMS equal to V naught divided by square root 2 because you want to calculate the VRMS. You already have a value of your V naught. V naught from your formula here. Alternating current has a function of the time. Okay, in the primary coil, which is referred to the input. Okay, then solve, you got your answer for the VRMS 240.4 volt. Okay, is it okay? Question 2, you want to calculate the VRMS output. Okay. VS, you want to calculate VS, secondary or output. You have a term of the VRMS. Okay. So by applying the formula NS divided by NP equal to VS divided by VP, okay, you have a number of N, NS 1800, okay, time with the VP here 240.4. You can get the answer from the previous answer here, answer from part 1, okay, okay, number 1, 240.4, okay, and then divide by 60. 60 is number of turn and P here, okay, and then so you got the answer for VS, okay, VRMS in output, okay, 712 volt. Okay, question 3, you want to calculate the V naught, okay, the maximum value of your voltage in output or your secondary coil. Okay, so VRMS output equal to V naught output. So your term must be the same. Here you have a secondary or you have output, and then here, because you want to apply VRMS equal to V naught divided by square root 2, the term must be the same. Output, and then you have also output here. Okay, then solve for the V output. Okay, you have VRMS output here, time with the square root 2. You got 10.2 times 10 power 3 volt. Okay, next, power, mean power in output or secondary coil. Okay, so output, the rest term also you must have output and output here. Okay, so IRMS output time with the VRMS output. Okay, you can calculate the power, mean power in output. Okay, so before that you need to calculate the IRMS output 7212, the value of your VRMS in output or secondary coil, divide by the R, okay, and then the get the current is equal to 0.7212, 0.7212 ampere, and that's all for your mean power in output. Okay, IRMS output time with the VRMS output, so you got 5201 volt. Okay, is it okay? Simple, right? Okay, that's all for this tutorial chapter 9. Okay. Okay, if you have a question, if you have a problem, you can ask me through a WhatsApp or contact, okay, through the email, okay, or through the LMS, okay. Thanks for watching the video. I will also upload the model exam paper for your final exam, and good luck, okay, for your final exam. See you later.